The kinetic molecular theory of gases is a set of assumptions that explain the behavior of gases. These assumptions are an oversimplification, but at this level they work and allow us to understand typical gas behavior. The first assumption of the kinetic molecular theory is that any gaseous chemical will consist of particles, usually atoms or molecules, moving randomly with no attractive forces between them. In other words, the kinetic energy of the particles is greater than the attractive forces between the particles. Kinetic molecular theory assumption 2 is that the amount of space occupied by the gas particles is negligible compared to the volume that the gas occupies. In other words, we pretend that gas molecules have zero volume. We know this isn't true, but molecules and atoms are so incredibly tiny that this assumption usually works. Kinetic molecular theory assumption 3 states that the temperature in units of Kelvin is directly proportional to the average kinetic energy of gas particles. That means as the temperature increases, gas particles move faster. We need to keep the temperature in units of Kelvin because Celsius has negative values, and that makes comparisons with other physical properties problematic. Kinetic molecular theory assumption 4 states that collisions between gas molecules or the wall of their container are elastic, meaning that energy does not get converted to heat during a collision, but stays as kinetic energy, which is transferred between gas particles. Any gas that obeys all 4 assumptions of the kinetic molecular theory is known as an ideal gas. Some gases are better at obeying these assumptions. Gas particles that are nonpolar and have low molecular weight are typically best at acting like an ideal gas. High temperatures and low pressure also help gases act ideally.